Question 5b. Okay, another Kirchhoff's current law question. First thing we need to do is decide which way to walk around the circuit. Again, it doesn't matter. We can choose a starting point, going from little to big, so I'm going to gain 9 volts. Okay, now which way is the current going? Well, the current's going that way, so it's going through that. The current's in the same direction as the way I'm walking around, so it's a negative, so it's minus 11 I1. Now we're continuing around our loop. The current's going the opposite direction to the way we're going, so it's going to be a plus 10I3. And then we're coming all the way back to our starting point. Kirchhoff's voltage law says the sum of voltages around a loop must equal 0, so that's fine. Okay, the next way around our loop, again, it doesn't matter, we can go this way. Okay, loop B. Okay, we can start over here, little to big. Okay, we're going to gain. We can start over here. Okay, we're going to gain 6 volts as we go across that, so that's plus 6. Okay, we're going to walk in the same direction as our current, so we're going to go minus 10I3. Okay, again, walking the same direction as our current, minus 5I2. Okay, same direction as our current, same direction as we're walking, minus 6I2. Okay, we see a like term there as we're writing our equation when we're back home, and we end up with 0. Okay, the third equation that we'll create is the current law. We've got I3 going in, we've got I1 heading in as well. So we've got I1 plus I3 equals I2. So that's our third equation, or I2. What comes out is equal to I1 and I3. I1 plus I3. Okay, we can rearrange this. We need to put it into the calculator in the same form as I1 plus I2 plus I3 equals a number. Okay, so if we rearrange this, I've got I1 plus negative I2, because if I bring that over to the other side, so it's minus I2 plus I3 equals 0. So that's our third equation. Okay, we come down here. This needs to be rearranged so it's in the right form for our calculator. Okay, having I1 first, so it's minus 11 I1 plus 0 I2 plus 10 I3. Okay, and that equals negative 9, because we have to move it to the other side, minus 9. Okay, for this last equation, okay, we've got some like terms in here. Do we have any I1s? No, so we've got 0 I1 minus 5 I2, but it's not 5 I2, is it? It's minus 5 minus 6, which means that it is minus 11 I2. So that's that gone, minus 10 I3. Now that equals 6, but it's going to go to the other side, so it equals minus 6. Okay, we now go through equations. We type them into the calculator, so we go up to menu, we come down here to equations. We go to simultaneous, which is F1. There's 3 equations, so we go to 3. Okay, we start off with, so it's 1, minus 1, 1 equals 0. So that's our first equation done. We come to a second equation. Now it's a minus 11. It is 0 for our second number. It is 10 for our third number, and that equals minus 9. Okay, we come over to our third equation. There isn't any I1 minus 11 I2 minus 10 I3 equals minus 6. Okay, we have our 3 equations, check that they look the same. Come over here and we push solve, and there we go. We now have our 3 equations. Now remember, our equation is in the form number I1, number I2, number I3 equals number. So the X here stands for I1, so we can write that all down. So we have our final equations with I1 equaling 0.7 I3 amperes. I2 being the middle one equals 0.633 amperes. And our I3 equaling negative 0.096. Okay, if we wanted just to check that rounding on that third one, we can come down here, if we push the FD button for fractions of decimals, so it's really 9.7 if we were to be correct. .097. Done. They're our three answers.